In this video, we're going to do an example where we're being asked to show that a function represented as a power series is a solution to a differential equation. So the function that we have in this case is a sum from n equals 0 to infinity of negative 1 to the n, x to the 2n over 2n factorial. And we want to show that it's a solution to the differential equation f double prime of x plus f of x equals 0. In particular, for it to be a solution to the differential equation, we need to plug in the second derivative and plug in the original function in the places where it says to and verify that we really do get 0 as a result. So starting off with our power series here, we have the sum from n equals 0 to infinity, negative 1 to the n, x to the 2n over 2n factorial. When we take the derivative, the 2n will come down in front, and then we'll have 2n minus 1 as the exponent over 2n factorial. Here, the first term was 0, so we lose that first term when we take the derivative, so the series now starts at 1. The 2n here will cancel with the 2n out in front of this factorial, so we're left with 2n minus 1 factorial. Second derivative will bring down the 2n minus 1, decrease the power by 1, and then this is over 2n minus 1 factorial. In this case, the series still starts at 1 because the first term here is not a constant. The first term is x. Actually, technically, it's negative x. But it's an x term, right? So when I take the derivative, that's not 0. Okay? So we still start at 1. We can cancel a 2n minus 1 on top and bottom, leaves us with 2n minus 2 factorial. Reindex, start this at 0 just because we're going to add it to the original f of x function, which also starts at 0. So that means I need to add 1 everywhere. I put an n plus 1 wherever I see an n. So I get negative 1 to the n plus 1. We get 2 times n plus 1. The quantity n plus 1, so I'll get a 2n plus 2 minus 2, so we just get a 2n, and the same thing in the denominator. And then I notice here I can factor out a negative sign out of this, and I get negative 1 to the n, x to the 2n over 2n factorial, with a minus sign in front, so this is the opposite of what we started with. So when we add them together, we really do get 0.